so we move on to the second speaker of this session. So I will introduce her, Emilie Henriksen. So she is a doctoral student in philosophy at the ENS, working on a thesis about the manifestation of time in relation to the algorithmic reason, so what she calls it, and based on the idea that algorithmic reason is which is composed of both cybernetics and artificial intelligence, and she seeks to explore this within the framework of Bergson's philosophy of time. Okay, so floor is yours.
I'm writing a thesis on the manifestation of time in algorithmic reason. A part of my argument is that algorithmic reason as it exists in society today, which algorithmic reason encompasses both the way in which algorithmic systems based on feedback reason and like kind of a broad understanding of what reason is, and the way in which includes also the way in which we reason about and with computational technologies. So my argument is, in a simplified sense, involves that contemporary algorithmic reason includes both tenets from artificial intelligence and cybernetics, because it includes feedback and also machine learning that at their core are cybernetic rather than within rather than a product of artificial intelligence. So my talk today, or my presentation, is an analysis of what I call the Bergsonian time of cybernetics. And it's an argument kind of in development. So I welcome all kinds of critical questions, but it's about the way in which the time of cybernetics lies closer to a Bergsonian time rather than the time of science or Einsteinian physics. So one of the problems, or one of the questions I'm working on, is to what extent the time of cybernetics is Bergsonian, like where is the divergence, which is important to my critique of time as it manifests in algorithmic reason. So I really hope all of this makes sense, because it's not a completely developed argument. So yeah, bear with me. So in cybernetics, as it was formulated in the beginning, Bergson was pretty present. So there were explicit references to the way in which the time of cybernetics was a Bergsonian time. So here is a quote from Masani's biography of Norbert Wiener from 1989, where he writes, I'm not going to read the whole quote, but he defines cybernetics as the extension of the scientific methodology necessitated by the existence of processes for which time is Bergsonian. So what does this imply? It relates to what has been described as the performative ontology of cybernetics, rather than the representational ontology of modern sciences, or sciences in modernity, and also of what is referred to as good old-fashioned AI, which developed around the same time or slightly later than cybernetics. And the reason for why it's performative is that it focuses on the behavioral systems or machines or organisms rather than the material makeup of entities. So it's not, for instance, it's not interested in what the brain is, like the anatomy of the brain, but rather what the brain does, and most of all, like how the brain adapts. So this leads to a quite interesting use of technology in order to study, for instance, the brain. So an example of that is the turtle robots, or they're usually referred to as turtles, built by the cybernetician Gray Walter in 1948, which is a robot which has two sensory inputs, one for light and one for contact or to simulate touch, and two motors. So basically through these sensory impressions, the robot moves. So it kind of explores the room. And the thing is that Walter didn't really know how the machine was going to behave before he made it. But it was based on the idea that the brain and the signals in the brain are binary and connected through neurons. So it's an interesting use of technology, not to build like technology as something useful for human beings, but as a way to test out a theory and try and get more, get information or try and understand how the brain processes information and also how it adapts. So a part of performative ontology is also this explorational view of the world. And it's not something that we should know the essence of and then act upon, but rather something to be explored. This robot, which he called Machina Speculatrix, is interesting because it adapts to its surroundings. However, it remains static in itself, so there is nothing internal in the robot that changes as it interacts with the world. A machine or technology that does that is a machine called the homeostasis, built by Ashby, which is a British cybernetician, and it was built at the same time as the turtles. And I'm not trying to explain exactly how it works because I've spent a lot of time trying to understand like the technological makeup of the homostat, but it's pretty complicated, at least for me, because as already demonstrated, my technical abilities are embarrassingly bad. But it was built to try and illustrate how a system could remain in homeostasis in a changing world. So as opposed to Walter's robots, it does not only respond to and adapt to its surroundings, it does not only explore its surroundings, but it also changes internally as it interacts with its surroundings or as its environment changes. So as part of this performative ontology is also a particular relationship to the future. So rather than having kind of this classic scientific relationship to time, which is about trying to trace causality in the past so that you can identify causal rules determining why something happens and therefore predicted future through trying to find causal rules. It is directed towards the future in that it assumes an explorative approach to reality. And this relates also to a particular view on time, where time is characterized by what is often referred to as undeterministic mechanics or mechanism. So the world is material, it is mechanic, but it is not deterministic. So the question posed by Walter when building his turtle robots was, how does the brain explore the world? And so his answer to that, as said, was not to dissect the brain, trying to understand how it works, but to build a model of the brain in order to see how does it actually interact with the world. And similarly, the question posed by Ashby was how a system can adapt to its environments whilst remaining ultra-stable within, and his answer was to build an ultra-stable system and let it engage with the world. And here is a very, I think, interesting quote from Ashby's autobiography, which really captures how central time was to cybernetics, and where it acquires an almost spiritual character, despite their emphasis on everything being mechanistic. So he writes that before he started researching or acquiring a cybernetic approach to the world, he hated change and he tried to avoid it. But now, through his research, he ended up becoming a time worshipper, seized with the extra fervor of the convert. And he refers to time as, religious, or in religious language, because it seems to be big enough and personal enough to be a possible object of veneration. And then he describes time in terms of, if you add time to something, it will adapt. And it is there you can almost trace kind of the creative aspect of time, which you also find in Bergson. So what is adaptability, and then what is intelligence, and what is life from a cybernetic perspective? Here, in kind of the founding article on cybernetics from 1943, written by Rosenbluth, Wiener, and Bigelow, talks about like teleological behavior. So the behavior studied by cyberneticians is a teleological one, because where causality implies a one-way, relatively irreversible functional relationship, teleology is concerned with behavior, not with functional relationships. So teleological behavior is purposeful actions which are controlled by the error of the reaction, which is negative feedback. And this is what they describe as intelligence, and that is why intelligence is not restricted to biological life, because as they have demonstrated, they can build automata which behave in this manner, which are able to adapt to their surroundings. So here, like intelligence, because they refer to this as intelligence, is reduced to this ability to behave teleologically. So intelligence is a matter of feedback, and therefore ultimately adaptation. So this is interesting in the context of AI, because especially like good old-fashioned AI was based on this idea that symbolic reasoning was an expression of intelligence, whereas contemporary AI is, first of all, like directed towards prediction, where an intelligent system is something that can predict, for instance, the way in which ChatGPT, for instance, predicts what kind of words or what kind of behavior the person using it is actually searching. So I find this interesting, because to be able to adapt to the future leaves the future as something unknown, something that can surprise you, and ultimately something that you cannot predict, because it is simply too complicated. So by focusing on adaptation as intelligence, it focuses on the system in the present, and if it is stable enough, and if it has efficient enough control mechanisms and communication mechanisms, it can adapt to a future which is unknown as the future unfolds. So as opposed to prediction, which aims to control the future and control time as it unfolds, to let the future be as knowable as the present, it kind of accepts how time unfolds. However, So then, of course, Bergson, he criticizes the time of the intellect because it finds truth in like the retrograde movement of truth, which he discusses in The Creative Mind, where the future, no, the past is viewed as through the lens of causal mechanism, which of course lets us anticipate the future on every occasion. But if intelligence in cybernetics centers on purposeful behavior and the ability to adapt to an unknown future, the question is then whether Bergson's criticism of the time of the intellect can actually be applied to cybernetics. But then there is another question which arises within the cybernetic attitude or the cybernetic framework, which is that if intelligence relates to adaptability, and creation relates to feedback and learning, because it's the element of time, the fact that time drives adaptation, which is the creative force within the cybernetic framework. But if creation only relates to feedback and learning as expressed in machine learning, what happens to chance and what happens to creativity? Because then you don't have any room for the spontaneous creativity, which Bergson discusses. And to understand what kind of happens to chance and what happens to creation, it is worth looking at the role of entropy within cybernetics, where the way in which Norbert Wiener describes entropy is probably, like, I find the most interesting interest point. So cybernetics, according to Wiener, is intimately related to life and through the perspective on death. And death in Wiener is the death of the universe, or it's the death of everything, which is entropy. So he describes life as kind of the resistance to entropy, because life is an island here and now in a dying world, because entropy is inevitable. So to be alive is to resist the general stream of corruption and decay. And this is what we know as homeostasis. So life is to maintain a pattern within homeostasis, because life, or we as living, are not stuff that abide, but patterns that perpetuate themselves. But if life relates to the repetition of patterns, which again is translated into machine learning, how, like, is there any space for radical newness? And then what is the relationship between life of Wiener and entropy as described by Bergson? And I believe that the way in which Bergson describes entropy in Creative Evolution, where he draws a line between old age and entropy, where you don't really have like the energy to do something radically new or for spontaneous creativity, rather you kind of repeat the old like basic patterns of survival, is kind of a bare resemblance to the description of life in Wiener. So entropy, according to Wiener, is when nothing really new ever happens. And there is nothing left but a drab uniformity out of which we can expect only minor and insignificant local fluctuations. But at the same time, he views life as the ability to perpetuate patterns, to repeat the same, or to remain in homeostasis as the world around you changes. So entropy, both entropy and life, has this emphasis on repeating patterns. Whereas in Bergson, life is movement and materiality is inverse movement, and each of these two movements is simple, the matter which forms a world being an undivided flux, and undivided also the life that runs through it, cutting out in it living beings all around its track. So because Bergson views the vital and the material orders as kind of distinct but intimately related, and creation as what happens in their inverse movements as reality which is making itself in a reality which is unmaking itself, kind of allows for this interaction between repetitive patterns and radical newness. But since time and space are ultimately the same, I would argue, in cybernetics, you end up with this kind of contradiction between life and creation and entropy, because they're all characterized by this repetitive action. So Wiener's criticism of Bergsonian time is based on an idea of yes, everything being a part of the same order, to use Bergson's terminology, because you can have mechanistic indeterminism. So even if the future is unknown, and even if the world is unpredictable, it is still reducible to a material and therefore spatial order. So in the first chapter in cybernetics, he refers to the modern automaton, so intelligent machines, which of course Bergson doesn't discuss. So I find it a very interesting criticism as an example of how vitalism is not a useful framework, because machines too can exist in this, can be vital in the way in which Bergson describes life. So he refers to the whole discussion between like a mechanistic and vitalist view on time and therefore of the world as a matter of badly posed questions, because vitalism has won the debate to the extent that even mechanisms correspond to the time structure of vitalism. But as we have said, this victory is a complete defeat, for from every point of view which has the slightest relation to morality or religion, the new mechanics is fully as mechanistic as the old. So the whole unpredictable time which allows for or drives creation in Bergson has been replicated in non-living machines. So you still have the same kind of creation, is the argument, as you would have in Bergson, but it's not limited to life. But then as I see it, the problem that arises from that is this view of life and death in the form of entropy bearing too much of a similarity, because the view of adaptation as life doesn't really allow any space for radical creation. Yeah, I'm done now, so I'm sorry if I don't know if I used all the time, but yes.
Okay, thank you for your presentation. So now, so this session has started in 10 minutes in delay, so we have 18 minutes. So yeah, we have plenty of time for discussion. So how would you, if you have any questions? Yes, so her presentation has lots of points of discussion. So yeah, so maybe people are preparing the questions. So meanwhile, I would like to ask you some preliminary questions. So first, you used in the title of your talk, algorithmic reason. So would you describe a little more about that? So yeah, in your talk, you discussed it in details, but to grasp the idea itself, so what that will be helpful for people, I think.
Yeah, so
How do you define the notion of the algorithmic reason and its relation to the cybernetics and the artificial intelligence?
So algorithmic reason is the way in which computational technologies have come to be viewed as the solution to heterogeneous sets of problems in the world, relating to everything from how to identify a strategic object in war, to how to organize a dating life, to how to evaluate risk in society. Computational technologies are viewed as the solution. And I argue that algorithmic reason is a style of reason, according to Ian Hacking's framework of what a style of reason is, because it's not only a way of thinking and therefore finding solutions to problems, it is also like it's wider than that, because it is a reason in the sense that it introduces new ways of determining what is true and false, and also new objects such as big data and computers and computational systems. So it is, yeah, a way of reasoning about the world. But in order to untangle like what that actually entails, I am focusing specifically on the emergence of computational machines that utilize feedback, which includes both kind of classical cybernetics, but also modern artificial intelligence. But my argument is that since artificial intelligence emerges from this representational ontology of the world, and also the conception of intelligence as the ability of symbolic reasoning or of formal logics, create some sort of internal tension within algorithmic reason, in terms of time. So that is kind of the starting point of my thesis, trying to untangle like what is that tension, but also argue that there is a tension, which is why I'm interested in cybernetics. But now I was talking mostly about first order cybernetics, but I believe that there are the same tendencies within second order cybernetics as well. Because yeah, the notions of like the technology of machine learning is based on feedback. It needs this world as it unfolds, and it needs also an undeterministic world, but symbolic reasoning is atemporal in nature. I don't know if that is an okay answer.
Okay, so yeah, so if you have, okay, so Katerina, go ahead.
Yes, thank you, and also thank you for this summary. It's been very, very useful to better understand your ideas. While I was listening to you, I was always trying to figure where the original vice, the original mistake of this intelligence, artificial intelligence was, and I thought it was exactly in the in its starting point in an already technological succession of time, so in already a spatial time, without being able to get in touch with the duration, as Bergson would have said. Is there any way that this kind of means, so technology, can get back in touch with its, like some would say, mystical origin, when in the two sources it talks about mechanics and mystics as two movements of a same elan, let's say, of a same movement, of a same development of the reality, two phases of a progress. Is there a way in which this kind of mechanics can get back in touch with its mystical side? And how do you see it? Can you recognize some of them? Because it's not just so simple to in Bergson as to say that the technology is just it's just the opposite of life. That's not at all. Technology, as the Homo Faber theory and this last chapter of the two sources shows, a very much more entangled relationship between technology and life. So between duration and space also in an ultimate level. So I would like to that you develop it.
Yeah. No, absolutely, and it's one of the problems with Wiener's criticism of Bergson is that his reading is kind of selective. He published a paper criticizing Bergsonism in 1915, and I kind of doubt that he read anything which was published afterwards. So I find his criticism interesting, but at the same time, I'm not entirely convinced. And as I tried to say in the presentation, I'm sorry, it was a bit messy, was that although cybernetics kind of engages, I would say, with the like durational time, like even on the level of being very interested in brainwaves, for instance, trying to like understand rhythms of brainwaves, is within, I would say, a durational framework. But the problem is that with like an exclusive emphasis on adaptation, you kind of don't leave space for spontaneous creation or like radical newness, which I view as one of the problems. But I would say that the main issue with algorithmic reason as it is today, which is completely removed from Bergsonian time, is the obsession of prediction, which I would say has like massive political implications, because the future is constructed as something that is dangerous because it is uncertain. So the only formulation of uncertainty that exists is one of insecurity. It is one of danger. So what we need to do is to always like try and preempt the future, which is fundamentally impossible, but also it removes us from the present. So I think that cybernetics, not all of cybernetics, but it gives us some sort of, it gives us a way to focus on the present being stable enough to sustain and like sustain the unknown, rather than removing ourselves kind of from the present, because our politics and also our technology is always directed as the future as dangerous. I don't know if that was an answer.
Okay. Yeah. So yeah, you put. Oh, okay. So Hisashi, go ahead.
Okay, thank you very much for your talk. I remember that when with Yasushi we were in UNS, you were there. So I don't know if you heard my talk. I talked about also on cybernetics and Bergson, and in that time I quoted one book of Yuk Fui. It called recursivity and contingency, and this book describes situate places Bergson in the course of certain evolution of philosophy of technology. And for Yukfui, Bergson is on, in a sense, on the pathway between the organized inorganic and organizing inorganic. And for that, so Bergson is on the pathway. So for Yukfui, he is not sufficient. So my question is very simple. So why Bergson to talk about cybernetics? For example, so for Yukfui, for example, Simondon or Stigler is better to understand cybernetics, philosophy of cybernetics. So why Bergson? Of course, I'm on your side. So because I'm against Yukufui's interpretation, but still, so we need explanation for this. And the second is a short comment. I would like to share a screen if possible. Is it possible?
Yeah, go ahead.
Okay, so it's this one. Do you see? Can you see?
Yeah, screen is very, very, how to say, small. So the
okay.
thin.
Okay.
Maybe more rectangular.
Okay.
The window.
Yeah. Is it better?
Yeah. Right. Yeah,
Okay.
better.
So this is pretty famous in Japan. It's what is called Bergsonian arc. So it's Shinichi Fukuoka invented this schema, and he tried to understand the phenomenon, a vital phenomenon, biological phenomenon with this schema. But I think it's perhaps applicable to understand the cybernetics structure. So it's just information. I wanted to say that there is certain schema, this kind of schema to understand cybernetics. Yeah, thank you.
The reason for why I think Bergson is better than philosophers that work more explicitly on technology, such as Simondon and also Stiegler, is that I find like what interests me is trying to understand if and if not why a machine cannot be alive. So rather than understanding what is the role of technology in our human experience, I'm interested in understanding if a machine can be alive. And I think Bergson is more applicable in that sense, which is why I mean, my thesis is interdisciplinary, and I'm not sure exactly within which disciplines, but I started out looking at philosophy of technology. But I ended up being more interested in philosophy of time and Bergson, namely because of the question of life. And I'm really sorry, but I didn't really understand the graph you showed. Can you show it again and maybe explain it again?
No, just it was just to show, so it was not to explain, but how to say, if you want, I can send after.
And also, the book you mentioned, it's called Recursivity
and Contingency.
Okay.
Yeah, Yukfui.
Yeah. So I think your talk has plenty of interesting points, but I think it would be better to articulate some how to say distinctions. I I have two things in my mind. So first, so when you put your talk in terms of the wording of feedback. I think it is not sufficient because feedback sounds like so the feedback and the prediction is not the same thing. The basic feedback is the primary version of the feedback is as so the static, the entity is static, and then something and it comes in and a reaction. So in reaction to that, the system reorganize and update its own system. So it's very slow. But in other on the contrary, the prediction, if system has prediction, it has an internal model. So before arriving the specific instance of reaction, so you have model, so you have prediction, so that is faster. So in the human development we have that, so in the baby state, in the very early stage of a baby, they can only use feedback. So they make mistakes, and after that they learn. But after that they have an internal model. With that they have more fluent movement in the duration. So that's why Bergson uses the duration. Our present need to have duration, a certain length of time, so in order to incorporate and input and the prediction of output. So that's very closely related to the Bergsonian notions of time. So your talk is related to the manifestation of time and with respect to the semantic strategies. So I think the distinction between these two. And recently it's a predictive coding framework or free work energy theories. These kinds of new theories are always every theory relies on this predictive framework. So this not just feedback. So this is very important for implement the more durational or manifestation of time. And another point it would be this relation to the prediction, also prediction. So what is the nature of prediction? So this is not you mentioned to the Bergson's critiques of the intelligent framework. So specialized time, So the prediction will have two forms, in two distinct forms. One is the intellectual, logical deduction way of prediction, but the other would be the more probabilistic, Bayesian inference, for example, So as I mentioned earlier, so the recent development of predictive coding relies on the Bayesian inference that relies on the probability distributions, So this is not a logical one-to-one deduction type of inference. They have much probabilistic inference. So, and that is also important for your wording, because you used algorithmic. I think this word is very important because not only because it contains rhythm. Hisashi will be interesting, but also algorithm is it involves, it's just not how to say deduction type of intelligence, So algorithm implies some more like tangible or procedural or way of calculating things, So I think that, so these distinctions. So first is reactive feedback, homeostasis, and the distinction of homeostasis and allostasis. Allostasis implies the prediction. So these two, and also the nature of the prediction. So way of the reasoning. So this is my suggestions. Okay. Okay, so maybe if you have a short comment for that.
Yeah, I'm really sorry. I did not mean to say that feedback and prediction are the same. Rather, I would say that they start out as being pretty different. So in the original formulations of cybernetics, before calling it cybernetics, Wiener wanted to refer to like the group of people working on this as teleological society, because feedback relates to teleological behavior, as in you have a goal of doing something, and then you receive negative feedback as to your how you are able to do whatever purposeful behavior you're about to do. Whereas prediction, as you rightly point out, is like many different, have many different formulations, but of course it's about predicting what is going to happen, whereas feedback would be your ability to do something that you're planning to do, and then trying to perfect it as it unfolds. So prediction would be, crudely, what I would say that the notion of intelligence is in contemporary artificial intelligence, which is this kind of conflation of future and present, always trying to make the future as knowable as the present, as if it has already actualized. And there are interesting like contradictions arising from that, but I did not want to say it was the same. But then feedback and prediction, especially in second order cybernetics, I think Stafford Beer is probably the best place to see that kind of are combined in an interesting way, because he, especially when he talks about exceedingly complex systems, which relates to kind of this black box ontology of cybernetics, where it is not only like behavior of systems or entities are of interest because like systems are so complex that you cannot actually understand what is happening inside them. And I mean, that is not only true for like machines, it's also true for human beings. If I read, like, if my behavior is directed towards like drinking a glass of water, the whole like process of what happens through the different signals and how like my muscles contract and all of that in order to do it are, even in modern science, kind of inaccessible. We don't know exactly how that works. So that is like one of the reasons why trying to understand the black box, this an unknowable system, is best done through behavior or studying behavior and how input leads to a certain output rather than understanding everything that is happening in between. So when Stafford Beer is talking about exceedingly complex systems, and also when he's talking about prediction, he's looking at, like, you're trying to predict the future, and then as the future unfolds, you look at how good your prediction was, and then you try and make your prediction better. So rather than knowing, like having a lot of data so that you can make some sort of model or equation about what is going to happen in the future, like that is too complicated. You cannot have all of the knowledge necessary to do that. You make a prediction and then you see to what extent it is right, and then that is a negative feedback onto your prediction, which is where the two notions are combined when it comes to like different formulations of like statistics. Wiener himself is very into like Gibbs's mechanical statistics, where chance is kind of a part of the universe itself. It's not only a question of us not knowing enough about how time unfolds for us to make perfect predictions. It is like, no, the unpredictable is part of, he describes it as the warp and weft of the universe. I don't know if that answered.
Okay, thank you. So sorry for the delay. So, but before closing this session, just one reference for you, Ellen. So there's a Collège de France lecture on the 1967. There is a collection of course about will, Bergson's lecture. So in that lecture, he developed a very deep theory about the prediction and prediction error, always monitoring the conscious about these differences. So maybe that helps in your.
Can you repeat the
Collège de France lecture 1967. So lecture about will. Okay, so sorry for my mistake. So it took too much a long time. So, but anyway, so thank you very much for the two speakers. So applaud them to.